Welcome to Moonlight Mysteries, a calm space for long research-rich mysteries. If you enjoy these sleepy deep dives, please like this video, subscribe, and tap the bell so you don't miss new episodes. If you'd like to support the channel, a quick comment with your favorite moment helps more people find us. Now settle in, dim the lights, and let's begin. The Tunguska Event. Introduction. In the quiet dawn of June 30th, 1908, the remote Siberian Taiga was wrapped in an early morning stillness. High above the pine forests near the Podkamennaya Tunguska River, a brilliant bluish streak suddenly tore across the sky. Moments later, the tranquility was shattered by an immense explosion, the largest impact event on Earth in recorded history. The blast's energy has been estimated in the range of 3 to 15 megatons of TNT, a force hundreds of times more powerful than the Hiroshima bomb. In an instant, over 2,000 square kilometers of forest were flattened, with an estimated 80 million trees scorched and toppled like matchsticks. Yet, in this vast zone of devastation, no impact crater was to be found, and no obvious fragments of a meteorite were ever recovered. The event seems to defy explanation, unfolding in a world far removed from civilization's gaze. For decades, the Tunguska Event would remain a cosmic mystery, a puzzle, news of thunder in an untouched wilderness. News of the catastrophe barely reached the wider world at first, as the area was so isolated under the rule of Tsar Nicholas II that it garnered little immediate attention. It was only years later, through scientific expeditions and collected eyewitness accounts, that the scale of what had happened became known. Awe and curiosity. And today, Tunguska inspires awe and curiosity. What force could cause the sky to split in two above Siberia? And what lessons has science drawn from this singular occurrence? In this long-form exploration, we journey back to that fateful morning and its aftermath. From the testimony of those who saw the heavens erupt, to the scientific detective work that followed, to the cultural legacy of Tunguska's enduring mystery. The tone is calm and meditative. The event's significance to picture the scene and ponder the event's significance in a reflective manner. Settling in comfortably, let us venture into the story of Tunguska, an event at the edge of living memory that still reverberates in scientific lore and popular imagination. With each step, we'll unfold the details in measured, gentle narration, suitable for a sleepy exploration of one of history's great unsolved cosmic mysteries. The morning the sky split apart. At approximately 30th, 1908 a.m. local time, on June 30th, 1908, indigenous Yankee nomads and Russian settlers in central Siberia observed an astonishing sight in the clear morning sky. A bluish-white fireball appeared moving rapidly from the east-southeast towards the northwest, leaving behind a shimmering trail. One witness recalled that the sky split in two, and fire appeared high and wide over the forest, lighting up the horizon with a pillar as if a second sun had risen. For an instant, it was as if a second sun had risen above the taiga, a searing light so intense that one man felt heat on his face as if his shirt were on fire. Then, as the fireball descended and exploded in midair, the sky went dark again. About 10 minutes later, a deep silence of shock broke as a series of powerful booms rolled across the land. Witnesses likened the sound to artillery fire or cannons firing in the distance. A colossal shockwave followed, strong enough to knock people off their feet and rattle buildings hundreds of kilometers away. Windows shattered in villages up to 200 kilometers from the blast, and the ground trembled as if an earthquake of magnitude 5.0 had struck. In the nearby trading post of Vanavara, around 65 kilometers south of Ground Zero, a farmer named Sergei Semenov was eating breakfast by a hot wind, was thrown violently to the ground by a hot wind that raced between the houses after the sky burst open. I was sitting by the house when suddenly the sky split in two, Semenov later testified. The split in the sky grew larger, and the entire northern side was covered with fire. At that moment, I became so hot that I couldn't bear it, as if my shirt was on fire. Then the sky closed, and a strong thump sounded, and I was thrown a few meters. Dazed, he saw a shockwave blow past, shattering windows and even snapping part of an iron lock on his barn door. Closer to the explosion, the effects were even more extraordinary. In a taiga camp on the Chambe River, not far from the epicenter, Evenki hunter Trujan and his brother were asleep in their hut when a sudden blast of hot wind flattened the forest around them. We heard of that and felt strong wind, Trujan recalled of that moment in an interview years later. The brothers were tossed in the air as their wooden hut collapsed. My body was pushed down by sticks, but my head was in the clear. Then I saw a wonder. Trees were falling. The branches were on fire. It became mighty bright. How can I say this? As if there was a second sun, and immediately there was a loud thunderclap. The sky, which had been clear and sunny just moments before, now held a towering cloud of black smoke and flame. The terrified Evenki boys crawled out from under the ruined hut and saw the forest around them leveled and burning. Over the next few minutes, they heard a succession of thunderous noises. Trujan described 4 or 5 distinct thunders, echoing through different directions as the shock waves reverberated through the atmosphere. The sequence of blasts and the mighty wind left the young men in shock, convinced that the world around them was erupting in chaos. From those further away, the experience was no less disconcerting. In the trading town of Kurensk, about 200 kilometers to the south, residents saw a strange glowing object low on the horizon that morning. A local newspaper described how peasants in a village north of Kurensk watched a strange, bright, impossible to look at, bluish-white, heavenly body streak across the sky for 10 minutes, As it neared the ground, this brilliant apparition seemed to smudge, then turn into a giant billow of black smoke, followed by artillery like large stones falling, or artillery fire. Buildings shook, and flames burst from the cloud. Panicked villagers poured into the streets. Women cried, thinking it was the end of the world, the newspaper reported. Even in places where the fireball itself was not seen, the sound and fury of the event made a deep impression. In the town of Kezemskoye, over 200 kilometers from the blast, people heard a sudden, loud, horrific thump that rattled houses, followed by an underground rattle in a prolonged series of 50 to 60 cannon-like booms over 5 minutes. Such reports came in from a vast region of Siberia, indicating that the Tunguska explosion's sonics through the air propagated for hundreds of miles through the air and ground. Incredibly, the effects of the mysterious blast did not end with the local shockwaves. In the days and nights after June 30th, 1908, skywatchers as far away as Europe and Asia noticed unusual atmospheric phenomena. Night skies glowed in eerie silver and gold, so much so that people in London and Scotland remarked they could read newspapers at midnight by the uncanny light. The Smithsonian Astrophysical Observatory in the United States observed a marked decrease in atmospheric transparency over the following months, likely due to fine dust particles dispersed high in the stratosphere by the explosion. An astronomer observatory in Ireland, an astronomer noted a nocturnal bright glow in the night sky on June 30th through July 1st, even though no moon was present. We now know these glowy silvery clouds to be noctilucent clouds formed by ice crystals in the upper atmosphere. It is believed that the Tunguska event injected vast quantities of water vapor in aerosol into the high atmosphere, seeding noctilucent clouds and causing brilliant sunsets and night glows across much of the northern hemisphere. Contemporary scientists were puzzled by these optical effects. One 1908 inquiry to the Times of London about the extraordinary light in the night sky when at the time. Only decades later did researchers connect the phenomenon to the Tunguska explosion, realizing that the drifting high-altitude haze was a global fingerprint of the blast. When the thunderous echoes faded and the skies eventually returned to normal, the Taiga fell silent again. The immediate toll of the Tunguska blast was surprisingly modest in human terms, owing to the remoteness of the area. There were no recorded mass casualties. There are no confirmed human deaths on record, though it's possible that 1 or 2 even key nomads perished in the wilderness near the epicenter. Herds of reindeers were less fortunate. By some accounts, thousands of reindeers grazing in the blast were killed or burned by the fire that followed. In reindeer Vinki clans who live by hunting in reindeer pastoralism lost camps and pastures to the conflagration. In an instant, a small corner of their world was obliterated. trees flattened outward from central point, animals charred, the land transformed into a scene of apocalyptic devastation. Those who witnessed it, or heard it unfold, or left trembling, unable to comprehend what they had just witnessed. In the absence of familiar cultural explanation, many turned to a familiar cultural belief to make sense of the chaos. A shattered taiga in a shaman's fears. The Tunguska explosion struck a region that was among the most isolated on Earth in 1908. The blast epicenter lay in the rolling taiga of what was then the Yeniseisk Governorate of the Russian Empire, today Krasnoyarski Krai, traditional lands, roads of the Evenki people's traditional lands. The Evenki, also known historically as Tungus, are an indigenous Siberian people, semi-nomadic reindeer herders and hunters, whose culture is steeped in shamanistic traditions and a deep reverence for nature. In 1908, their way of life had changed little for centuries. They dwelt in trooms, teepee-like tents, and followed the seasonal migration of game and reindeer across the endless pine and larch forest. Scattered among them were a few Russian settlers, traders, trappers, and peasants who lived in small villages or at trading posts. There were no cities, no railroads, and not even a telegraph line in the immediate vicinity of Tunguska. News traveled by word of mouth on horseback or along the rivers. It is no wonder, then, that the outside world remained largely oblivious to the event for a long time. For the Evenki, who witnessed the fire from the sky, the experience was framed in spiritual and religious terms. The shamans of the Evenki held that powerful spirits and gods governed the natural world. Thunder and fire from the heavens might be seen as expressions of the spirit's wrath or warnings of supernatural forces at work. In the aftermath of the Tunguska blast, some Evenki came to believe that they were being punished by a deity called Agdi or Agda, the god of thunder. According to later ethnographies, local lore held that Agdi had struck down the forest and animals in anger, perhaps due to the tribe's transgressions or internal discord. The charred, flattened forest at the blast site was deemed cursed, a place where, in the Evenki phrase, the fire god had descended. For years, they avoided the area, fearing that the ground was poisoned by evil spirits. Hunters skirted the edges of the devastation, but were reluctant to venture into the fallen forest, where nothing left standing. This cultural interpretation provided a measure of understanding for the Evenki, but it also meant that, for decades, no local inhabitants dared to closely investigate the Tunguska Ground Zero. The Russian settlers, for their part, were equally bewildered. Many had never heard of meteorites or cosmic impacts. Instead, they suspected a massive volcanic explosion or even the end of days. Keep in mind that this was an era without modern mass media in these hinterlands. No radio broadcasts or instant news to explain the event. Siberia in 1908 was still a frontier under the fading regime of Imperial Russia, which had more immediate concerns, like political unrest in looming war, than a mysterious explosion in the far wilderness. Thus, the Tunguska event initially slipped into obscurity outside of Siberia. A brief report or two in the Siberian newspapers described the unusual atmospheric occurrence and noted the panic of the villagers, but there was no follow-up at the time by authorities in St. Petersburg. The Tsar's government did not send any expedition to inquire. In fact, it appears few in the central government even knew about the incident beyond vague rumors. For 19 long years, the charred Tunguska forest lay untouched and mostly unseen by outsiders. Meanwhile, the world moved on. Russia was convulsed by World War I, the 1917 revolutions, and a civil war. By the time stability returned under the Soviet Union in the 1920s, the Tunguska story had become something of a regional legend. Tales of the day the sky exploded were told by the Evenki around fire camps, and by Russian villagers to curious visitors, preserving the memory of the event until scientists could finally arrive to study it. It was in this context, a land of myth and deep isolation, that the first scientific investigators would eventually enter Tunguska, guided by the recollections of those who had witnessed that fateful morning. Before we follow those investigators into the field, let us pause to understand what modern science say about the cause of such a blast. To truly appreciate Tunguska, we must step back and look at the cosmic context, the nature of asteroids and comets that roam our solar system and occasionally intersect with our fragile planet. Cosmic origins, asteroids, comets, and falling stars. What could have caused the sky to erupt over Tunguska in 1908? Today, nearly all experts agree it was the explosive airburst of a cosmic body, most likely a small asteroid, or possibly a comet fragment that collided with Earth's atmosphere. To understand this, we need to explore how asteroids and comets form and behave. These objects are often called the leftover rubbles of the solar system, ancient materials dating back to the formation of the Sun and planets 4.5 billion years ago. Asteroids. Asteroids are essentially small, irregular planets. Astronomers sometimes refer to them as planetesimals, the building blocks that never coalesced into a full-fledged planet. In the early solar system, countless rocky bodies circled the Sun. Most of the would-be planetesimals in the inner solar system either merged into the terrestrial planets or were gravitationally scattered. A great many, however, found a home in the asteroid belt, a broad ring of objects orbiting between Mars and Jupiter. It was the immense gravity of Jupiter that prevented these rocks from accreting into another planet. Instead, they have remained for eons as a swarm of smaller bodies. Asteroids range in size from Ceres, a dwarf planet 940 kilometers across, down to boulders with only a few meters wide. The vast majority are much smaller than moons, often irregular in shape and pockmarked with crater from collisions with each other over cosmic time. Asteroids are composed of a diverse mix of materials. Some are primarily metallic, made largely of iron and nickel. These are fragments of the cores of ancient protoplanets that broke apart. Others are stony, rich in silicate rocks, while many, especially the carbonaceous asteroids, contain a wealth of carbon, organic compounds, and primitive dust. In fact, most asteroids are not solid monoliths, but rather rubble piles, loose conglomerations of rock held together by gravity after ages of being cracked and shattered by impacts. Only the largest asteroids are coherent solid rocks, explains planetary scientist Humberto Campins. Smaller ones have been broken up so much that they resemble piles of debris in space, which has implications for how they break apart in an atmosphere. Even the more solid asteroids typically aren't composed of a single pure element or mineral. They tend to be mixtures. Even the metal ones are not just one element, Campin notes. They're usually a combination of iron, nickel, and a little bit of silicate. This composition matters when an asteroid strikes a planet. It can influence whether the object penetrates deep or explodes high, and how much debris it produces. Numerous asteroids periodically cross Earth's orbital path. These are termed near-Earth objects, asteroids, and some comets that have orbits bringing them into the inner solar system. Over time, gravitational nudges by planets can send asteroids onto collision courses with Earth. On a daily basis, our planet is bombarded by tons of space dust and sand grain-sized meteoroids that burn so harmlessly as shooting stars. Several times each year, larger rocks a meter or more across enter the atmosphere, sometimes exploding as dramatic fireballs high in the sky. But these are generally too small to cause damage on the ground. They either disintegrate or at most drop a few meteorite fragments. The danger comes from those rare objects that are tens of meters across or larger, the size range capable of causing Tunguska-scale destruction or worse. Statistically, astronomers estimate that an asteroid roughly 50 meters in diameter, comparable to the Tunguska impactor by most estimates, might strike Earth once every few centuries or millennia. Because the planet is mostly ocean and empty land, such an event would likely occur in a remote area, as Tunguska did. But if it happened over a populated region, the consequences would be catastrophic. For perspective, a Tunguska-sized asteroid impact over a major city could destroy a metropolitan area entirely, potentially killing millions. Smaller asteroids on the order of 15 to 20 meters, like the one that entered over Russia in 2013, are believed to hit Earth roughly once per century on average. Indeed, the Tunguska Event of 1908 and the much smaller Chelyabinsk meteor of 2013, which exploded over a Russian city and injured over 1,600 people, seem to be examples of these once-in-100 years occurrences. And tellingly, they both happened in Russia, largely by chance. Larger impacts, such as the 10 to 15 kilometer asteroids that wiped out the dinosaurs 65 million years ago are thankfully far less frequent, occurring on the scale of tens of millions of years. Humanity has never recorded an event of that magnitude, but Tunguska stands as the most extreme cosmic impact in living memory. Comets. Another class of cosmic visitors could also be responsible for aerial bursts like Tunguska, and for good reason. Comets are often called dirty snowballs, and for good reason. They are primarily composed of ice, frozen water, carbon dioxide, ammonia, and other volatiles, mixed liberally with dust and rocky material. Comets originate in the cold outer reaches of the solar system. Many reside in the distant Oort cloud, nearly a light year away, while others come from the closer Kuiper belt beyond Neptune. They travel towards the Sun on elongated, highly elliptical orbits, developing spectacular luminous tails of gas and dust when solar heats cause their ice to sublimate into vapor. If asteroids are the dry rocks of the inner solar system, comets are the ice vagabonds of the outer solar system, paying only occasional visits to the inner planets. When it comes to impacts, comets differ from asteroids in a few key ways. First, their composition, icy and fragile, means they are even less likely to reach the ground intact. A small comet entering the atmosphere at high speed might vaporize more readily than a denser, stony asteroid. Second, comets typically approach the Earth at much higher velocities. A long period comet falling from the outer solar system can slam into the atmosphere at well over 50 kilometers per second, whereas an asteroid in an Earth-crossing orbit might hit at, say, 15 to 20 kilometers per second. Kinetic energy scales with the square of velocity, so an object moving 3 times faster delivers 9 times the energy on impact. This means that a smaller comet could produce an explosion equal to a larger, slower asteroid. The extreme speeds also makes comets harder to detect before they arrive. A comet on a first visit from the Oort cloud could appear with only months or weeks of warning, whereas many near-Earth asteroids are cataloged years in advance. Historically, no comet impact has ever been conclusively documented on Earth in human history. Most large documented impact craters and events are attributed to asteroids or meteorites. This is one reason Tunguska fascinates scientists. If it were proven to have been caused by a comet, it would stand as a unique case of cometary impact in the modern record. Some early investigators of Tunguska indeed suspected a comet. In 1930, British astronomer F.J.W. Whipple hypothesized that the Tunguska body was a fragment of comet Encke, which has a short period and was known to produce a meteor shower, the Beta Terids, peaking in late June. The timing of Tunguska coincided with that meteor shower, lending a tantalizing hint. Perhaps Earth ran into a dense clump of debris shed by Comet Encke. Proponents of the comet hypothesis point to the lack of an impact crater and the reports of glowing nocturnal skies as evidence. A comet made largely of ice could have vaporized entirely in midair, leaving no solid fragments, while dispersing fine, icy dust that contributed to the unusual sky glow. On the other hand, Soviet scientists in the 1960s and beyond increasingly leaned toward an asteroidal origin for Tunguska. They noted that a stony asteroid of sufficient size can also explode in the atmosphere and leave no crater, as evidently happened. Additionally, some chemical analysis of the soil and peat in the Tunguska region have detected meteoritic material, elements like nickel and iridium in higher than normal concentrations for that locale. These could be fingerprints of an asteroid, as asteroids often have a different elemental makeup than comets, which are more ice-rich. The debate over asteroid versus comet for Tunguska remains in many decades, and as we will see, remains an open question in some respects. But regardless of which type of object it was, the mechanism of destruction was the same. A high-speed cosmic body collided with Earth's atmosphere and detonated in an airburst, delivering immense energy to the environment without ever hitting the ground directly. Fire in the sky. The physics of an airburst. When a small asteroid or comet plunges into Earth's atmosphere, the outcome depends on its size, speed, angle of entry, and composition. The Tunguska cosmic body, estimated at roughly 50 to 60 meters wide and about 130,000 tons in mass, streaked into the atmosphere at over 50,000 kilometers per hour. The entry angle has been estimated at around 30 degrees from the horizontal, meaning it was a relatively shallow trajectory, not a straight down plunge, but more like a skimming dive into denser air. As the object hurtled lower, the atmospheric pressure in front of it built up enormously, compressing and superheating the air in its path. By about 10,000 kilometers above the surface, that is 6 to 7 miles high, the stresses became too great. The bolide, such as incoming fireballs, fragmented and then exploded in a furious release of energy. In an instant, the object was obliterated into a superheated cloud of vapor and molten debris. The surrounding air was raised to temperatures of perhaps 24,000 degrees Celsius. That's over 40,000 degrees Fahrenheit, hotter than the surface of the sun. As indicated by some estimates, this incandescent fireball rapidly expanded, generating a blast wave and intense flash of thermal radiation in all directions. Down below, on the ground directly beneath the explosion, the effects were paradoxical. Trees stood upright, but singed and stripped of their branches, as though a gigantic blowtorch had roared down from above. This was the epicenter of the airburst, where the downward directed force was intense enough to sear the forest, but somehow spared a small inner zone from the full horizontal blast in a roughly 8-kilometer radius area near the ground zero. Later investigators found these curious standing trunks charred poles with all their limbs blown off. This eerie sight testified to the nearly vertical component of the shocks. The explosion's center was above them, and the pressure wave pushed downward, defoliating and burning the trees without toppling them. Further out, the situation was different. As the blast waves expanded spherically from the airburst, it struck the ground at an oblique angle around the perimeter of the epicenter. The result was a vast, radical pattern of felled forest. Trees up to 30 to 40 kilometers away were snapped like toothpicks and laid out on the ground, all pointing outward from the central blast zone. Aerial surveys and field maps later showed the fallen timber arranged in a butterfly-shaped pattern, a symmetric swath of destruction, with lobes reflecting the blast's directional energy. This pattern provided critical clues to the event. By analyzing the direction in which trees fell, scientists could triangulate the likely altitude and position of the blast in the sky. Indeed, the Tunguska forest turned out to be a natural physics experiment left on the landscape. It told of an explosion coming from above rather than a single point on the ground, and its butterfly outline suggested the incoming object had a particular flight direction and attitude when it blew apart. Along with the shock wave, the exploding bovide emitted a fierce flash of heat and light. Witnesses, like Simonov, reported the sensation of their clothes and skin suddenly getting hot, even tens of kilometers away. People saw the pillar of fire in the sky and felt thermal radiation intense enough to ignite fire on the ground nearest to the blast. The forest immediately below most likely combusted. Later expeditions found signs of burning and carbonization on the surviving tree stumps in the epicentral area. Some accounts describe the taiga catching fire shortly after the shock wave passed, and charred trees were observed around the outskirts of the affected zone. It is likely that the combination of the heat flash and the friction of wind, the gale-force blast of a hot air balloon, set off hundreds of small fires. These would have merged into a conflagration that consumed additional forest acreage in the minutes and hours after the blast. Indeed, one Evenki witness recalls seeing the branches on fire as they looked at the fallen trees around them moments after the explosion. The Tunguska explosion, thus, had a double destructive effect. First, the concussive force of the shockwave flattening everything, and then the outbreak of wildfires that likely burned for days, denuding the area further. However, heavy winds and perhaps the turbulent updraft from the explosion may have extinguished some fires. Reports vary, and by the time scientists arrived years later, new vegetation had obscured some of the burned evidence. Another invisible but significant effect of the Tunguska airburst was its impact on the atmosphere and environment beyond the immediate vicinity. The air pressure wave from the blast rippled through the atmosphere, circling the globe. Barographs in London, Washington, D.C., Jakarta, and other distant cities recorded subtle pressure oscillations in the hours following the explosion. These were the same kind of pressure waves that would later be noted after nuclear tests in the 2013 Chelyabinsk yield, a testament to Tunguska's immense yield. High above, the fireball and shockwave likely produced nitric oxide by shattering atmospheric nitrogen and oxygen molecules. One scientific analysis suggests that up to 30 million tons of nitric oxide may have been formed in the stratosphere and mesosphere by the Tunguska blast's shockwaves, leading to elevated levels of nitrogen compound that, in turn, caused acid rains over Siberia and even ozone layer depletion for a few years. Indeed, ice core samples in tree ring studies have hinted at unusual chemical signatures around 1908 to 1910, possibly linked to the Tunguska Event's atmospheric fallout. Such global environmental effects were short-lived, but they underscored the Tunguska explosion's power. It did not merely flatten a forest, it also perturbed the upper atmosphere of the entire planet. Crucially, all this destruction happened without a crater. Unlike a typical meteorite strike, where a single impact gouges a hole in the ground, Tunguska's energy was released entirely in the air. The explosion occurred at an altitude of roughly 5 to 10 kilometers above the surface. By the time the blast waves reached the swampy forest floors, the cosmic intruder had been vaporized into tiny droplets and dust. For this reason, no obvious meteoritic debris was initially found. The object was essentially atomized in the atmosphere. It is sobering to realize that if the Tunguska meteoroid had been made of stronger stuff, say solid iron, or had been bigger, it might have punched through to the ground and excavated a crater, causing more localized damage. But its composition and trajectory meant that Earth's atmosphere itself acted like a giant safety cushion, forcing the intruder to explode in midair and sparing the ground a direct impact. The Tunguska event, thus, taught science a valuable lesson. Airbursts are a distinct hazard from cosmic impact, different from crater-forming strikes, but potentially just as devastating over a broad area. The physics of airbursts were not well understood in 1908. After all, humans had never witnessed such a thing. It would take many years, in the advent of high-energy explosives and later nuclear bomb tests, for scientists to fully grasp how an explosion in the sky could flatten a forest on the ground. The search for evidence. When the dust settled after the Tunguska blast, one mystery loomed large. Where was the meteorite? In the wake of the event, no one in 1908 ventured into the epicenter to look for an impact site. But it was widely assumed, once news of the blast eventually spread among scientists, that a sizable meteor or comet must have hit the Earth. Typically, a meteor fall leaves something tangible, a crater, piece of iron or rock, blackened meteorites scattered about. Tunguska offered none of these obvious signs. This absence of an impact crater puzzled researchers from the very beginning. in 1927, when the first scientific expedition finally reached ground zero. To their astonishment, there was no giant hole in the ground. Instead, as one member of the team described, there was a zone roughly 50 kilometers at the center of where the trees were scorched and devoid of branches, but still standing upright, surrounded by miles after miles of fallen trees lying in neat radial rows. The leader of that expedition, Leonid Kulik, had expected to find an enormous iron meteorite buried in a crater. What he found was more akin to the fallout of a gigantic aerial bomb. The lack of a crater was the first clue that the Tunguska cosmic body exploded above the surface, rather than striking it directly. This kind of mid-air disruption can happen when the forces on a meteoroid, from pressure and heating, exceed its structural strength. Think of an object hitting the atmosphere at Mach 50 plus. It's like hitting concrete. If the object is not solid enough, it will break apart violently. In Tunguska's case, the prevailing theory is that the object was either a fragile stony asteroid or a comet, something that would fragment easily. A solid iron meteor, like the one that formed Meteor Crater in Arizona around 50,000 years ago, might have punched through to the ground, but a loosely held together mass, a stony body or icy conglomerate, blew to bits in the dense air, dumping its kinetic energy in the atmosphere rather than in the soil. As a result, no large pieces survived to gouge a crater. In a sense, the atmosphere itself was the impact surface. The energy that would have carved out a crater was instead expended as a blast wave in the sky. Over the years, scientists and enthusiasts have scoured the Tunguska area for any physical remnants of the impactor. Early expeditions found tiny, tantalizing hints. For example, microscopic silicate and magnetite spheres were discovered embedded in the resin of trees and in the peat bogs of the region. These small melted droplets could be condensed material from the vaporized meteoroid, thrown out by the explosion and then raining down. Chemical analyses of soil and peat layers from 1908 have shown elevated levels of nickel, iridium, and other elements often associated with meteorites. One study in the 1990s even claimed detection of isotopic anomalies in nitrogen trapped in peat, suggesting the effects of acid rain or extraterrestrial matter from the event. However, findings have sometimes been contradictory. Some teams reported an iridium spike, others did not. What is clear is that if any solid fragments of the Tunguska object reached the ground, they must have been very small or deeply buried in the boggy soil. There is one enduring hypothesis about a hidden Tunguska crater, Lake Checo, a tiny bow-shaped lake located about 8 kilometers north-northwest of the explosion's epicenter. Lake Checo is an anomaly in the local geography. It's fairly small, really deep, around 50 meters across, unusually deep, around 50 meters deep in the center, and has a conical bottom shape. In 2007, a team of Italian and Russian scientists proposed that Lake Checo might fill an impact crater left by a fragment of the Tunguska meteoroid that survived the main airburst. Their surveys found that the lake bottom sediment was thinner than expected if the lake were thousands of years old, and magnetometer readings suggested a dense object, perhaps a meter in size, under the lake's deepest point. Moreover, the long axis of Lake Checo points roughly towards the calculated ground zero of the explosion. As one might expect if an incoming chunk flew off that way, these clues are suggestive. Could a 10-meter piece of the cosmic body have plunged into the soft, swampy ground, liquefying permafrost and creating a water-filled crater? Not all scientists are convinced. Other studies argue that Lake Checo predates 1908. A Soviet investigation in 1961 measured sediment layers and inferred the lake might be at least 5,000 years old, far too ancient to be a Tunguska crater. However, the Italian researchers countered that those early studies misinterpreted the deposition rates, and that only the top meter or so of sediment, which could correspond to about 100 years of it, they suspect is undisturbed. Below that, they suspect a disturbed layer, possibly from the impact event. The debate continues in academic journals, with papers falling back and forth. Lake Checo is a Tunguska impact crater versus Lake Checo is not an impact crater. As of now, the mainstream view is that the Tunguska event did not leave a traditional crater, and Lake Checo's origin remains unproven. It may simply be a small glacial lake or an oxbow lake from the nearby river. My one-day gilling or seismic studies of the lake bed might one day give a definitive answer. Even without a crater, the felled forest of Tunguska served as a long-lasting record of the event. The toppled trees remained lying in place for decades, preserving in the dry, cold climate. Observers in the 1920s and 1930s could still clearly see the radioblast pattern. Some of those shattered trunks can be seen to this day, though much of the area has since been reforested with young growth. In the immediate aftermath, however, the zone was a wasteland. The Evenki spoke in hushed tones of a cursed clearing where nothing remained alive. They believed the great fire spirit had descended and scarred the land. Little did they know that within their lifetime, scientists from far-off cities would come trudging through the marshes and mosquitoes of Siberia, determined to uncover the truth behind this cosmic visitation. Investigating Tunguska, expedition into the blast zone. It was not until 1927, a full 19 years after the Tunguska explosion, that a scientific expedition finally reached the remote disaster site. This delay was due to a combination of the region's inaccessibility and the tumultuous history of Russia in the intervening years. By the late 1920s, the newly formed Soviet Union was keen to demonstrate its scientific prowess, and the mystery of Tunguska presented a perfect opportunity. The Soviet Academy of Sciences, approved an expedition led by Leonid Kulik, a mineralogist and meteorite expert who had spent years studying reports of the event. Kulik was convinced that an enormous meteorite had fallen in Siberia, and he persuaded the authorities that it was worth searching for because of the scientific value and even the possibility of salvaging meteoric iron. Kulik's team traveled by Trans-Siberian Railway, river steamboats, and eventually horse-drawn carts to reach Vanavara, the nearest trading post to Ground Zero. From Vanavara, they hired Evenki guides to take them into the trackless taiga. The journey was arduous. They had to contend with swamps, clouds of mosquitoes, and the sheer remoteness of a place few outsiders had ever trod. As they drew near the suspected site, guided by eyewitness testimonies collected along the way, the first thing they noticed was the flattened forest. Even from a distance, they could see a swath of fallen trees. I still cannot sort out my chaotic expressions, Kulik wrote, describing his first view of the devastation. From our observation point, no sign of forest can be seen, for everything has been devastated and burned. One has an uncanny feeling when one sees thick giant trees snapped across like twigs, and their tops hurled many meters away. Kulik was stunned. The scene exceeded even what he had imagined from witness reports. Millions of trees were down, radiating out from a central area where only blasted trunks remained. The pattern was, as he put it, a whole majestic picture of a unique meteorite fall, an impact unlike any other in recorded history. Over the next several weeks in 1927, Kulik's expedition surveyed the area meticulously. They mapped the treefall directions, took photographs, and searched for the meteorite itself. Initially, Kulik believed the meteorite must have buried itself below the marshy ground of the suspected epicenter. Finding a peat bog that seemed especially disturbed, he theorized that the meteorite, or fragments of it, might lie beneath those murky waters. He even attempted some preliminary digging, but the conditions were difficult and his resources limited. On subsequent expeditions, Kulik returned in 1928, 1929, and 1930. They brought better equipment. They drained small bogs with pumps and dug into the permafrost, hoping to strike a chunk of cosmic iron. But nothing conclusive was found. There were moments of excitement. At one point, Kulik found a circular pothole in the ground and thought it might be a small crater. But it turned out to be a natural pond. Despite his exhaustive efforts, Kulik never found the meteorite fragment he sought. He did, however, leave with a trove of data, counts of fallen trees, measurements of their orientations, testimonies from local witnesses, and samples of soil and peat for laboratory analysis. This foundational work confirmed to the scientific world that something extraordinary had happened at Tunguska, even if the smoking gun, the meteorite itself, remained elusive. Kulik's dedication bordered on obsession. He and his team endured extreme hardships in the swampy taiga, At one point, Kulik contracted malaria during an expedition and nearly died in the field. In another instance, members of his party fell through ice during a winter approach. Logistics were so challenging that even reaching the center of the blast zone was an achievement. The locals were initially wary of helping. One account tells that an Evenki family refused to guide Kulik further because they believed evil spirits haunted the impact site, and that Kulik's insistence on going there would bring misfortune. Kulik had to persuade and pay others to continue. His perseverance paid off in that the mystery of Tunguska was firmly established as a subject of scientific inquiry rather than mere folklore. When his findings were published and photographs of the blasted taiga circulated, scientists around the world took note and began proposing theories. In the decades following Kulik's pioneering surveys, Tunguska continued to intrigue researchers, especially within the Soviet Union. Given the difficulty of reaching the formal expeditions were intermittent. However, an interesting development occurred in the 1950s. A group of interested enthusiasts and scientists formed what would become known as the Complex Amateur Expedition, inspired in part by new ideas, including the fringe notion of an alien spacecraft explosion, which we'll discuss later. These groups started making annual summer treks to Tunguska in 1958 and thereafter. Initially, many of the participants were just curiosity operators, students, or just curiosity seekers. But over time, they gathered substantial scientific data. They cooperated with professional scientists from the Academy of Sciences, setting up systematic surveys and experiments. These expeditions mapped the biological regrowth of the forest, examined tree rings for growth anomalies, collected more microsamples from peat and resin, and even installed instruments on site to monitor any magnetic or radioactive peculiarities. One notable figure, geochemist Eugene Kolesnikov, participated in the later Tunguska expeditions and conducted extensive chemical analyses. In the 1960s and 70s, his team extracted cores from peat bogs and reportedly found unusual elemental concentrations in the 1908 layers, including iridium, an element often enriched in extraterrestrial objects. They also claimed to find tiny fragments, with compositions hinting at a stony meteorite. These findings strengthened the case that the cause was indeed cosmic. Other studies in the 1970s looked at tree ring patterns. Trees that survived on the periphery showed a slowdown in growth after 1908, possibly due to environmental stress, like changed soil chemistry or climate effects from the event. By contrast, young trees that sprouted in the clear zone grew abnormally quickly in the high sunlight of the open ground, creating a band of dense young forest around the epicenter by the 1950s. Such ecological observations highlighted Tunguska as not just an isolated blast, but a longer-term environmental disturbance in recovery, a unique natural experiment in forest ecology following a sudden devastation. In the 1990s and 2000s, Tunguska research gained an international flavor. Western scientists, who had mostly relied on Soviet reports throughout the Cold War, finally had opportunities to collaborate on site. Probably the most high-profile of these efforts was the 1999 Tunguska 99 expedition, a joint Italian-Russian venture led in part by the University of Bologna physicist Giuseppe Longo. Longo had been fascinated by Tunguska since 1991, when he first visited the area to collect microscopic particles from tree resin. In the summer of 1999, his team undertook a comprehensive study of Lake Checo and its surrounding area. They flew in heavy equipment by helicopter, echo sounders, ground-penetrating radar, coring drills, magnetometers, and more, to thoroughly probe the lake in the bogs. Over weeks of work, tormented by legendary Siberian mosquitoes and difficult weather, they mapped Lake Checo's bottom and retrieved sediment cores. The bathymetric data indeed showed an unusual conical depth profile, leading them to postulate it might be a crater. However, the sediments were over 10 meters thick, which initially suggested an older origin, if one assumed typical accumulation rates. Yet, they reasoned that much of that sediment might have washed in rapidly after a sudden event, a possibility that kept the impact crater theory alive. Their cores and samples, when analyzed by a smoking gun, did not yield an unequivocal smoking gun. There was no obvious chunk of meteorite in the lakebed, only that magnetic anomaly that hinted something dense lying under the mud. The team did not find further tiny spheres and chemical traces in the peat surrounding the lake consistent with an impact plume fallout. In the end, the Tunguska 99 team leaned toward the interpretation that Lake Checo could be a secondary impact site, but they carefully noted that it was not inconsistent with a natural formation either. Follow-up expeditions in 2008 and 2009 returned to Lake Checo with improved instruments, and debates continue in the literature. As of the late 2010s, consensus was still not reached, illustrating how Tunguska's riddles persist despite modern technology. Meanwhile, other modern approaches have been applied to Tunguska studies. Satellite imagery and even LiDAR mapping have been used to analyze the pattern of tree regrowth and any lingering topographical scars. Because the area is now a state natural preserve, the Tunguska Reserve, established 1995 to protect the site, researchers have to coordinate with reserve authorities for any on-site work, which has somewhat limited large expeditions in recent years. Nonetheless, interests remain high. In 2017, studies by a joint European team examined polar ice cores from Greenland for traces of Tunguska, hypothesizing that if the explosion lofted material into the stratosphere, some might settle at the poles. They reported no clear iridium spike in 1908 layers, but did note elevated titrate levels consistent with nitrogen oxide from a massive airburst. Another interesting angle was a 2020s hypothesis connect June to a potential meteor swarm in late June, the Beta Turrets. A group of astronomers even proposed doing radar observations during the turret swarm to see if any large Tunguska-like fragments lurk among them. Tunguska has thus become a case study in planetary defense circles as well, prompting questions like, how do we detect and prevent another Tunguska? We will touch on these forward-looking aspects in the conclusion. Through all these efforts, one thing is clear. The Tunguska event has never been truly solved in a way that satisfies everyone. We know the broad strokes, a cosmic object exploded in the air, but the precise identity of that object, comet or asteroid, what type, its exact trajectory, and details of the explosion are still being refined. Yet, what was once wild speculation has been narrowed by decades of patient science, and in the process, Tunguska's story has grown richer, encompassing not just physics and astronomy, but also ecology, cultural history, and even a dose of the paranormal and imaginative. Theories and speculation. The Tunguska explosion's mysterious nature, no crater, no large recovered fragments, witnesses describing bizarre phenomena, inevitably gave rise to a spectrum of theories about what really happened. Over the years, explanations have ranged from the soberly scientific to the wildly fantastical. In this calm late-night exploration, we will survey these theories, understanding that even the fringe ideas played a role in Tunguska's legend. The standard model, stony asteroid airburst. Today's prevailing theory holds that Tunguska was caused by a stony asteroid, approximately 50 to 60 meters in diameter, that entered the atmosphere and exploded in an airburst 5 to 10 kilometers above the ground. This would make it a member of the class of near-Earth asteroids that sporadically intersect Earth's orbit. The asteroid theory is supported by the evidence of high temperatures and a powerful shock wave, consistent with a rock slamming into the atmosphere at high speed. The lack of a crater implying mid-air disintegration, and the slight find of meteoric material in the area. In the 1990s and 2000s, sophisticated computer simulations bolstered this explanation. For instance, in 1993, a team led by Christopher Taiga at NASA Ames modeled the atmospheric breakup of a stony asteroid and showed it would produce a blast pattern very much like Tunguska's, flattening trees over a broad area without an impact crater. Later, Russian researchers Artemiev and Shuvalov simulated a 50-meter asteroid vaporizing 8 kilometers up, and their results matched many features of the event, including the distribution of fine debris and the possibility that some small fragments could reach the ground as meteorites. One question that came up was how big was the Tunguska asteroid? early estimates of the energy yield were as high as 15 to 30 megatons, which implied an object perhaps 60 to 80 meters across. But some newer research by Sandia National Labs, led by physicist Mark Bosloff, suggested that the blast's effect could be explained by a smaller energy yield, maybe only 3 to 5 megatons, if one considers the downward direct jet of the exploding fireball. Bosloff's 2007 simulation indicated the mass of the object might have been less than previously thought, perhaps closer to 30 meters in size, because the airburst's energy was not spherically symmetric, but focused towards the ground, amplifying damage directly below. If that's true, that's somewhat reassuring. It would mean Tunguska's sized events are a bit less frequent than once thought, since a smaller asteroid can yield that damage. Regardless of these nuances, the stony asteroid hypothesis remains the leading explanation. The icy intruder comet fragment hypothesis. A persistent alternative theory is that the Tunguska object was a fragment of a comet, essentially a clump of mostly ice and dust. This idea was notably championed by Soviet scientists in the mid-20th century, including astronomer I.S. Ostapovich and others, who found the notion attractive because a comet would neatly explain the absence of any solid debris. A comet is like a cosmic snowball that could entirely vaporize during an atmospheric entry, leaving little or no residue except water vapor and fine dust. The comet Encke connection we mentioned earlier is a specific variant of this hypothesis. Encke's comet is responsible for the annual Beta Turid meteor shower in late June, and calculations show that in 1908, Earth would indeed have been near a denser stream of that meteoroid swarm. Perhaps Tunguska was caused by an unusually large particle from this cometary debris. Of a comet. Skies offer a poetic hint in favor of a comet. What if the high-altitude noctilucent clouds were seeded by the icy remains of a comet's nucleus? Proponents argue that only a comet could produce such copious high-altitude ice to cause the prolonged white night after the event. However, critics point out that a stony asteroid blast could likewise loft water vapor from the ground or combustion in fine particles to high altitude, so the night glows are not a smoking gun. Additionally, certain volatiles struggles a bit with the lack of certain volatiles in the aftermath. For example, one might expect unusual isotopes of hydrogen or helium common in cometary material, which haven't been clearly identified in Tunguska samples, though not definitively looked for either. In truth, as of now, it's hard to conclusively distinguish a comet from an asteroid based purely on the ground evidence at Tunguska. Both would have been moving fast and blown apart similarly. Many experts lean asteroid simply because near-Earth asteroids are far more common statistically as impactors than long-period comets. Yet, some notable like the late Nobel laureate Vitaly entertained the comet idea for Tunguska, keeping it in the discussion. It remains an intriguing possibility, emphasizing how special Tunguska is. If it was a comet, it's an exceedingly rare case of one hitting us. If it was an asteroid, it's a stark reminder that even relatively small asteroids can pack a tremendous punch. Exotic explanations. Beyond the natural scenarios of rock or ice from space, Tunguska's mystery sparked a host of exotic theories that veer into the speculative and some would say fanciful. These ideas arose largely because, for many years, no one had a definitive answer, and the human imagination abhors a vacuum. Let's look at a few of the most famous alternative hypotheses. Micro black hole. In 1973, two American physicists, Albert Jackson and Michael Ryan, published a paper in the journal Nature asking, was the Tunguska event due to a black hole? They proposed that a tiny primordial black hole, a leftover from the Big Bang, might have passed through the Earth at Tunguska. In their scenario, to a black hole with a mass perhaps comparable to a large asteroid, but compressed to subatomic size, would have zoomed through the Earth like a bullet. As it rushed through the atmosphere, it could compress air and produce a shock wave accounting for Tunguska. Then it would tunnel through the Earth's interior and exit on the other side, possibly creating a second disturbance, which they speculate might have been an unobserved splash in the Atlantic Ocean. The black hole idea was an imaginative attempt to explain the lack of a crater in Fragments. After all, a black hole would leave nothing tangible behind. Time magazine even ran a piece on this theory in the 1970s, reflecting public fascination with such a bizarre concept. However, the hypothesis doesn't hold up well to scrutiny. A micro black hole passing through Earth would have caused very different seismic signals than those recorded in 1908, and we would expect an exit event that was never found. No reports of a simultaneous mysterious blast on the far side of the world. Subsequent analyses showed the Jackson-Ryan black hole idea was not consistent with observed data, and the scientific community regards it as an intriguing but highly unlikely footnote in Tunguska lore. Antimatter meteor. Another outlandish idea floated in the 1960s was that perhaps an antimatter chunk hit Earth's atmosphere and annihilated upon contact. Antimatter, the mirror substance of ordinary matter, releases pure energy when it meets regular matter, so an antimatter rock would indeed cause a tremendous explosion with no debris. However, if such an event occurred, it should have also produced an intense burst of high-energy gamma radiation, like a nuclear bomb's gamma flash. No evidence of such radiation has ever been found in tree rings or nitrate deposits from 1908. And modern physics understanding suggests natural macroscopic lumps of antimatter just don't exist in our neighborhood. So this theory quickly faded, surviving mostly in science fiction realms as a plot device rather than serious science. UFO explosion. Perhaps the most famous and enduring alternative theory is the idea that Tunguska was caused by an exploding alien spacecraft or an alien technology. This notion began not in fringe conspiracy circles, but interestingly, with a science fiction story by Soviet author Alexander Kazantsev. In 1946, Kazantsev wrote a short story, The Explosion, later variation titled A Visitor from Outer Space, in which he imagined that a Martian spaceship, powered by a nuclear reactor, suffered a catastrophic accident over Siberia and blew up in midair. Kazantsev was inspired by the then recent bombings of Hiroshima and Nagasaki. He noticed the Tunguska blast had similarities to a nuclear explosion: bright flash, mushroom-like columns, forests flattened radially, and creatively surmised an alien nuclear-powered craft might explain it. Although offered as fiction, the idea captured the public's imagination. In the 1950s and 60s, as UFO fever grew worldwide, numerous writers and UFOologists repeated and embellished the spaceship hypothesis. They pointed to the lack of crater and the seeming intelligent timing, some saying it exploded before hitting the ground, maybe deliberately to avoid a worse disaster, as evidence of extraterrestrial origin. The Soviet interest in Tunguska was partly revitalized. Indeed, some of those early amateur expeditions in the late 1950s headed to Tunguska hoping to find remnants of an alien device. None were found, of course. Over time, the spaceship theory remained in pop culture fringe. No credible scientific evidence ever emerged. No mysterious alloy fragments, but artifacts have been discovered in Tunguska. But the idea of an alien cause became a popular trope. It has shown up in countless novels, TV shows, and comics. While fun to contemplate, this theory is not supported by any hard data. It lives on as a modern legend, rather than a hypothesis testable by science. Tesla's death ray. One of the more peculiar claims involves the famous inventor Nikola Tesla. In the early 20th century, Tesla was experimenting with wireless transmission of energy and even hinted at inventions that could direct beams of destructive force, what the press later dubbed death rays. Decades after Tunguska, some writers posited that Tesla might have been testing a large-scale energy weapon from his Wardenclyffe Tower in New York, aiming it across the globe, and that Tunguska was the unintended target or demonstration. There is no evidence Tesla did any such thing, and in 1908, his Wardenclyffe facility was actually non-operational, and he was financially struggling. This theory is almost certainly post hoc myth-making, but it finds occasional mentions in conspiracy-flavored discussions. It speaks to Tunguska's mystique that people have tried to link it to everything from Atlantean superweapons to interdimensional phenomena. Geophysical theories. A minority of explanations looked for Earth-based causes. One idea was a massive natural gas explosion. The Tunguska region sits above some coal beds and peat bogs, so one Soviet scientist proposed that perhaps a huge pocket of methane gas seeped out and ignited in an airburst. However, that doesn't explain the initial fireball trajectory, seen moving across the sky. Another speculation was whether a volcanic explosion or a bolide of geographic origin, like a huge chunk of meteorological formed ice called sky ice, might be to blame. These have not held up to scrutiny either. The lack of seismic precursor or any volcanic activity in that area rules out an eruption or ground-based explosion. In the end, extraterrestrial exotic theories have displaced the conventional extraterrestrial impact explanation, but the Tunguska mystery definitely benefited from the interplay of science and fantasy. As historian Andy Bruno noted, there was no neat division between science and fantasy in the history of Tunguska research. Enthusiastic amateurs, driven by cosmic fantasies, still gather real data that helped scientists. For example, those UFO-inspired expeditions of the 1960s ended up mapping the area thoroughly and contributed to legitimate hypotheses, like the comet theory in new asteroid models. Tunguska, thus, it's a scientific roads of fact and folklore. It's a scientific riddle, yes, but also a canvas onto which people have projected fear and hope, be it fear of cosmic disaster, hope of contact with otherworldly intelligence, or warnings about technologies in the wrong hand. Cultural echoes. Tunguska in art, media, and imagination. For an event that occurred in an uninhabited corner of Siberia, the Tunguska explosion has cast a long shadow in popular culture. Its tantalized numerous references in colossal scale have inspired numerous references in literature, film, television, and games. Let's gently explore how Tunguska has been portrayed and commemorated in the creative realm, all while maintaining our calm, narrative tone, as if we're recounting a fantastical legend, which in a sense, Tunguska has become. One of the earliest cultural responses was in Soviet science fiction, as we've seen with Kazantsev's 1946 story that seeded the alien spacecraft idea. This story was hugely influential within the USSR, with speculative fiction, the known data of Tunguska, with speculative fiction. It opened the floodgates for Tunguska to be a topic not just for scientists, but for storytellers. Over time, Tunguska became a byword for any mysterious cataclysm. In Russian, the term Tunguska, sometimes colloquially, implies a big bang or an enigmatic disaster. The event has been referenced in Russian literature and film, occasionally as a plot device. For example, a 1987 Soviet film, Through the Thorns to the Stars, aka in a subplot, Astra, touches on Tunguska in a subplot involving alien visitation, showing how ingrained the idea was. In the West, as information about Tunguska filtered out, it also captured, after the 1950s, it also captured imaginations. The renowned American novelist Thomas Pynchon made Tunguska a part of his sprawling narrative in the novel Against the Day, 2006. In the story, Pynchon devotes 2 chapters to a fantastical recounting of the Tunguska event, blending it with themes of mysticism in early 20th century science. He calls it the event in the sky and uses it as a symbol of sudden, unexplained change, reflecting perhaps how the real event intrude without warning. World-altering forces can intrude without warning. Pynchon's treatment is one of the more literary homage to Tunguska, rich in imagery and metaphor, ideal for a meditative reading or listening late at night. The realm of science fiction and fantasy literature has countless Tunguska-inspired tales. Often, Tunguska is reimagined as something other than an asteroid. In some stories, it's the crash of a spaceship. In others, it's the detonation of an alien weapon, or even a temporal incident. Time travel stories sometimes make Tunguska the result of a botched experiment in the future. Tunguska has appeared in comic books as well, notably in the Hellboy comics, in a cult relic from to supernatural forces, part of one storyline tying the event to supernatural forces. On screen, Tunguska has made its way into popular TV shows. Perhaps best known example is The X-Files, the 1990s series mixing government conspiracy and paranormal investigation. In a two-part episode titled Tunguska in Terma, Season 4, 1996, Agent Mulder and Scully tracked a mysterious black oil virus that, in the show's lore, was first unearthed at the Tunguska blast site. The X-File writers used Tunguska's mystique as a backdrop for their plot about alien contagion in Soviet secrets, firmly planting the word Tunguska into the vocabulary of pop culture. Around the same time, other TV or deep mystery. It's briefly mentioned in some documentary series on unsolved mysteries and even in animation, for instance, Futurama. Video games have not missed the chance to incorporate Tunguska's allure. In 2006, a graphical adventure game called Secret Files Tunguska was released, later ported to Nintendo Wii in 2008. In this game, the protagonist investigates her father's disappearance and uncovers a conspiracy involving the Tunguska Event, which in the game's narrative is caused by extraterrestrial forces. The player travels through Siberia, solving puzzles related to the 1908 experience in atmosphere. The Tunguska Event thus provides an atmospheric, mysterious foundation for the game's story, proving that even a century later, this real-world incident can serve as a compelling fictional fodder. Other games have alluded to Tunguska as well. The Assassin's Creed series, known for weaving historical events into its lore, has a few nods to Tunguska in its expanded universe. In a 2018 expansion for the game Zombie Army 4, even imagined Tunguska as a Nazi occult experiment gone wrong. The fact that Tunguska can be slotted into alternative histories and paranormal plots so easily speaks to while there has legendary status. In film, while there hasn't been a major Hollywood movie solely about Tunguska, yet the event often gets mentioned in documentaries about asteroid impact. It is the prime exemplar of a modern impact. For instance, the docudrama Meteorites, 1998, opens with the dramatization of Tunguska, showing reindeer herders being tossed by a fiery blast, a scene likely inspired by the Chuchan and Chakran account. The image of a lonely forest being suddenly flattened by cosmic intruder is cinematic by nature, and one can imagine it vividly. A flash, a wave of trees bending and falling, animals stampeding, then silence, except for crackling fire. Such scenes have been recreated in educational programs on channels like Discovery and History, often with CGI, to illustrate what an asteroid airburst would look like. These visualizations bring to life the descriptions we have cited with calm wonder, helping audience picture the nearly unimaginable. Beyond entertainment, Tunguska has had an impact on popular consciousness about science and danger. In 2005, the United Nations declared June 30th as International Asteroid Day, precisely because of the Tunguska anniversary. Around every June 30th, media outlets often published explainers or retrospectives on the Tunguska event, keeping its memory alive. It serves as a rallying point to discuss planetary defense, the effort to detect and prevent asteroid impact. In essence, Tunguska has transcended from being an obscure cosmic incident to being a global symbol of the cosmic threat we face and our responsibility to address them. NASA, ESA, and other agencies frequently reference Tunguska when highlighting the importance of asteroid tracking programs. It's a case study in why we must not ignore the skies. This interplay between Tunguska's scientific significance and its cultural imprint is fascinating. The event shows up in music as well. For example, a progressive rock band named Tunguska makes instrumental tracks inspired by cosmic themes in a movement of the symphony Gloria by Dmitri Shostakovich was supposedly influenced by the idea of a great mysterious explosion. Though not explicitly titled Tunguska, the timing suggests he had heard about it. Meanwhile, in the realm of the quirky, Tunguska has even been the namesake for odd things. A cocktail named Tunguska Blast pops up in mixology circles, a particularly strong drink. And a roller coaster in Slovenia is nicknamed Tunguska for its explosive speed. All these examples paint a picture of how Tunguska has entered the collective imagination. It stands alongside phenomena like the Bermuda Triangle or the Great Pyramids in terms of being a magnet for theories, except Tunguska is very much real and scientific. It reminds us that sometimes reality itself provides the most awe-inspiring story. As we recount, we might feel a kinship, gentle storytelling. We might feel a kinship with those even-key storyteller who, before scientists arrived, could only explain Tunguska as the deed of a thunder god. Today, our gods are technology, aliens, science fiction dreams, and scientific equations. And Tunguska finds a place in all of them. Conclusion. Now, as our narrative journey nears its end, let's step back and reflect on what the Tunguska event means for us today. Over a century later, the area that was once a blasted wasteland has largely healed. New forests have grown over much of the leveled zone. Larch, pine, and birch now stand where charred stumps once protruded. In 1958, to mark the 50th anniversary, the Soviet Union even issued a commemorative postage stamp with Kulik's portrait in a depiction of the flattened forest, symbolizing how this scientific mystery had become part of national heritage. The site of Tunguska explosion is today protected as the Tunguska State Nature Reserve, a designation that both honors its scientific value and preserves the environment. Visitors, a few intrepid tourists and researchers each year, can trek to the epicenter, often guided by local Evenki rangers. There, one might still find signs of 1908, perhaps a toppled dead trunk half sunk to the moss, or an odd hum. A small monument has uprooted tree's root ball. A small monument has been erected in that quiet clearing, commemorating the event in Kulik's expedition. In a way, Tunguska has become a memorial to Earth's vulnerability and nature's resilience. The forest was obliterated, yet life returned. Humanity was caught unawares, yet we eventually learned and adapted. The Tunguska Event has had a profound impact on science. It alerted us to the reality that the cosmos can affect Earth, not just over geologic for a long time, but on random Tuesday mornings. For a long time, the idea of asteroid impacts was primarily associated with ancient extinctions like the dinosaurs, or confined to science fiction. Tunguska brought it into the present, especially after the Chelyabinsk incident in 2013. Tunguska's lesson has been reinforced. These things do happen. 20 meters wide, still smaller meteor, about 20 meters wide, still injured over 1,000 people, mostly from shattered glass due to the shock wave. It was a tangible reminder that Tunguska was not a one-off freak event, but part of a continuum of cosmic hazards. In response, our society has started taking planetary defense seriously. NASA established its Planetary Defense Coordination Office in 2016, coordinating efforts to find and track near-Earth objects and to develop contingency plans. In a testament to how far we've come, NASA's DART mission in 2022 successfully demonstrated a method to deflect and prevent the next Tunguska, essentially a technology to prevent the next Tunguska if we ever spot it coming. Each year, on Asteroid Day, June 30th, scientists and communicators around the world use the Tunguska story to engage the public about why we search the skies and how we can be prepared. In the realm of ideas, Tunguska also reminds us of the limits of our knowledge and the beauty of mystery. Imagine it is late at night and you are listening to this tale. You can almost picture that immense fireball tearing through the atmosphere. Something primal and not fully tamed by comprehension. It's humbling to realize that in 1908, this happened without any warning, literally out of the blue. And it was only luck that it struck an unpopulated area. The Earth bears the scars of far worse impacts in the past. The giant crater in Mexico from 65 million years ago, the meteor crater in Arizona formed 50,000 years ago by an iron meteor about 30 meters wide. Tunguska sits at the small end of that scale. Yet, if it had occurred over a city, the devastation and loss of life would have been unprecedented in modern times. This realization has subtly permeated our collective consciousness. Tunguska is often cited as a cautionary tale in discussion, not just of asteroids, but of unexpected natural disasters in general. A symbol that even in our advanced age, nature or the cosmos can surprise us profoundly. And yet, there's comfort in knowledge. Today, unlike in 1908, we have eyes on the sky. Hundreds of astronomers in automated telescopes scan for near-Earth objects nightly. Thousands of asteroids have been cataloged and their orbits projected. While we haven't found every object out there, the biggest civilization-threatening asteroids have been mostly accounted for, and none pose an imminent threat. Tunguska-sized objects are trickier. They're smaller and fainter, but efforts are underway to deploy space-based infrared telescopes that can spot these dark wanderers. We have also learned from Tunguska scientifically. Its data has been used to model nuclear explosion effects, to understand how airbursts can cause forest fires, and even to interpret possible similar events in the ancient past. Bronze Age city insists that an airburst leveled a Bronze Age city in the Middle East, and Tunguska's physics were used as a comparative model. In a poetic sense, Tunguska connects to the themes of human curiosity and wonder. The explosion itself was a grand, if terrifying, natural spectacle. It left those who saw it babbling in awe and fear. And ever since, it has prompted us to ask big questions. What was that? Could it happen again? And are we alone in the universe? Those Evenki witnesses in 1908 may have thought the world was ending, or their gods were angry. In a way, Tunguska did mark an ending, the end of the world as it had always been, a world where humanity didn't consider rocks falling from space as part of our reality. Post-Tunguska, and especially post-Kulik's expedition, we enter a new awareness that the heavens and earth are interconnected in dynamic, sometimes violent ways. As you drift in this calm narrative, picture one more scene. It's a summer evening in Siberia at the Tunguska Nature Reserve. The sun is low, casting golden light over the endless taiga. A gentle breeze whispers through young birch trees. In the distance, a wooden sign marks Kulik's old campsite. The air is pure, and there is birdsong. Nature has reclaimed this place. If you walk a little, you might stumble on a weathered stump, a silent witness from 1908. Touch its charcoal gray surface. You are literally touching history, feeling the remnants of a tree that saw the sky catch fire. The calm that surrounds you now belies the chaos that once was here. It's almost as if the earth has exhaled and returned to equilibrium. But the lore of that morning persists in scientific journals, in adventure games, in whispered legends. Tunguska teaches us to be vigilant, yet also fills us with wonder at the strange universe we inhabit. In concluding our comprehensive journey, we acknowledge that the Tunguska event remained in some measure an open story, not all questions answered, which is part of its enduring charm. But far from being just an unsolved mystery, it has become a cornerstone in our understanding of planetary science, from the Evenki for creative endeavors, from the Evenki tale of the thunder god's wrath, to the modern scientists' data models of asteroid fragmentation. Tunguska spans the spectrum of human response to the unknown. Let the last thought be one of contemplation. We gaze up at the stars now, with slightly different eyes, knowing that occasionally one of those countless tumbling rocks in the solar system might pay us an explosive visit. Yet we also take comfort in how much we have learned since that early summer morning in 1908, in the tranquil silence of the Siberian twilight. The legacy of Tunguska is both a warning and an inspiration, a cosmic reminder to cherish our world and to keep seeking knowledge, even in the face of great mysteries.